The approach I'm going to show you now, it's inspired from research in generative art. Generative art is basically to create artistic pieces from rules or from structures that are predefined and can have many combinations, many forms of expression, many forms of configurating, and thus have the capacity to create beyond what the rules are in principle written. So among those generative language approaches, one of those is called reaction networks. The reaction network approach was taken by Christian Jendreiko, Vincenzo De Florio, myself, and other researchers in the group Systemic Modeling Research. So let me explain you now what a reaction network is, and then we will discuss more features of it. So the reaction network framework begins with two fundamental structures or ideas: the species and the reactions. In order to illustrate the example of the reaction network we are working with, I will explicitly speak about one reaction network which contains three species: A in red, B in blue, and C in yellow, and 5 reactions which we will note as R1, R2, R3, R4, and R5. Species might represent anything we want in principle. They are inspired by chemistry, where they are supposed to mean atoms or molecules. But we can think of species in a more general sense as if they will be ideas, musical notes, mathematical formulas, expressions, political beliefs, products or resources, economical goods, whatever we want. And that is the idea, to use reaction networks as a framework for representing models in general and not just chemical systems or musical systems. And this is why it can be used as a form of generative art, because you can think of anything, colors, whatever you want. So we will explain later what these molecules are specifically in our case, but I'm explaining the language at the moment. So we have species A, B, C for illustrating our network, and the reactions, which are 5 in our case, have the following structure. We have the left-hand side, which is called reactants. The species play the role of reactants, and it means that they will come together to react. That's why they are called reactants. And when that happens, when the molecules come together, they transform each other and become products. So the reactants become products by the happening of a reaction, which is conditioned by the species forming the reactants of the reaction getting together. And that's what the plus sign means. They are getting together and they become another collection. So the first reaction basically tells that A becomes B when it gets together with B. And also the second reaction explains that B in isolation will turn into A. The third reaction expresses, very similar than the first, but instead of having B, has C, that A becomes C in the presence of C. And similarly to the second, the fourth says that C will turn into A. The fifth reaction, what it does is to show a slightly more complex reaction, because it combines B and C to create A. So this combines the 3 species in one reaction, whereas the other 4 reactions only combine 2 species per each reaction. This is the simplest reaction network we can create to have certain complexities that we are interested on, and we leave you with our reaction network. Thank you.
Yeah, so what Stefan, Werni and I did, we took this special reaction network that was developed by Tomas Veloz and Vincenzo De Florio, and we gave it a special interpretation. The species in our case are operations that we operate on our electronic devices for producing and manipulating music. The 5 reactions we see from reaction 1 down to reaction 5, we read this setup as a score. So we start playing with reaction 1, then we move on to reaction 2, reaction 3, reaction 4, and reaction 5. And the species are, as I said, operations. And we have, of course, 3 operations. So A, this operation is the operation of condensing. B is the operation of expanding in one direction, and C is also expanding, but in the opposite direction of the expansion of species B. And during performing these operations, due to the score that we have right here at our hands, we decide what are the properties of the musical configurations that we are expanding or condensing. And this is basically the concept of the composition, that is a composition of Tomas Veloz, Vincenzo de Florio, Stefan Werni, and myself.